episode 228. Welcome to Data Skeptic, a podcast about data science and fake news from an algorithmic perspective. Here's your host, Kyle Polich.
Coming to you from Chicago, Illinois. Welcome to the only podcast banned from more sites than Alex Jones. This is Data Skeptic. Hey Chicago, sorry we didn't meet up again. I had a great time at the Mendoza College of Business meetup earlier this year, but I'm in and out really quick this time. Next time. Today, we're going to start asking more algorithmic questions about fake news. How can machine learning solve this problem? Algorithms pretty much won the battle when it comes to spam, but fake news is not spam. With spam, users give you useful signals, like ignoring the spam, deleting it quickly, unsubscribing. And that's just behavioral, that's not even the content. With fake news, the same old features aren't going to work. As we've heard in previous weeks, fake news gets clicks, it gets shared. Perhaps some of that metadata is bot-generated, but it's there nonetheless. On today's show, I interview Kai Xu about exactly that question. Specifically, about how one can use machine learning to detect fake news. In the second half, I speak with Mike Tamir about a project he's been contributing to that you can try for yourself, which is designed to classify URLs as fake news or not. Well, Kai, welcome to Data Skeptic.
Thank you, Kyle, for invitation. I'm happy to be here.
A few weeks, maybe a few months ago, as I was getting into my own research on fake news, I came across your excellent paper, Fake News Detection on Social Media, a data mining perspective. And you and your co-authors have done a pretty extensive literature search in addition to your own work. To begin with, could you tell me a little bit about how you got interested in this topic?
So actually, because of last summer, we noticed that in 2016, that in the election season, people mention a lot about fake news on social media and then how people are affected by this fake news problem and then a lot of things going on there. In the summer of 2016, I began to look into this problem and then I noticed that there are a very few work like taking deeply into this problem and then looking into what's going on. So I start to do a literature survey and then try to understand this problem more deeply.
What about fake news detection is difficult? Why do people regard this as a hard problem?
Fake news can spread very fast on social media. People can create content by themselves with no policy to restrict them. In social media, people may be affected by their friends and followers and who they follow, right? So the fake news is very challenging because the fake news content is very, very similar to real news. Even though that the fake news maker, they want to intentionally spread something that is false, but in terms of the content, it's very hard to differentiate. That makes the traditional natural language processing method doesn't work. That's why we try to find new algorithms, new perspectives to solve this problem.
Can you tell me a little bit about how you formalize the problem?
The easiest way is that to formalize the fake news and real news binary classification problem. This news is fake and this news is not fake. But we can also formalize the problem as a continuous problem. For example, I say, okay, this news has 80% likely to be real or fake. Fake news are those news that are intentionally to spread and they are false. So true and false, there's a clear bound. So that's why we finally try to formalize the problem as a binary classification problem. If the news has some content that's intentionally to be fabricated, then this news is absolutely fake. So it's a binary classification problem.
So is the key distinction around the fabrication? Because, of course, I could report a real-world situation, but heavily slant it. You know, if I didn't like a politician, I could say they showed up and had a stain on their shirt and they mumbled. And, you know, I could describe a real event, but describe it in a very unpleasant light. Would that be considered fake news?
Not necessary. What you mentioned is that you may have some bias when you express something. You say, if you don't like this person, then you say maybe the sentiment is very negative. Does not necessarily mean that the content you are saying is fake. The writer knows this thing is not right. He or she still writes something about that. That's the difference here.
One of the things I really liked about your paper was it was the first research I had read which formalized the problem of fake news from a game theoretic sort of point of view. Could you talk a little bit about how you structured the two-player strategy game?
We're trying to understand why people believe fake news and why those publishers, they spread fake news, right? So essentially in this whole journalist system that we have different players. For example, the publisher, we have the readers and other spreaders, these different kind of actors. So for example, for the publisher, why they spread fake news? I think there are mainly two kinds of incentives. Of course, they want to make revenue. For example, if they come up with some very catchy, some interesting stories, people like to read it and people spread it, and then they may get a lot of attention. They can gain revenue, right? Yeah, and on the other hand, there is a political gain. For example, in the election season, that some people spread a lot of news articles with respect to some president candidate, something like that. So they want to spread their opinions. They want to change people's mind to support their candidates. So there's a political gain here going on as well. This is from the public's point of view. And from the readers or consumers' point of view, when we read the news, there are actually some psychology theories supporting that we are more likely to see or believe the news that we think they're right. It's called confirmation bias. If we think this candidate is good, then we are more likely to believe the news that's supporting him is good, whether or not it's fake or real. So there's a lot of psychology theories going on here. As a human, it's very difficult for us to differentiate. For us, it's like we are working on machine learning and data mining, try to filter out some of the fake news or real news on social media. For example, the Twitter data, we can see that for a specific user, whether this user is, for example, newly created, but suddenly he published a lot of tweets supporting some candidates or something, or this user is more likely to be suspicious or not based on what he tweets. One example is that if this user has following a lot of people, but very few people following him, then this user is more likely to be some less credible user. For example, the bots. As you know, the social bots has been shown to play a very important role in spreading a lot of fake news. So we do consider a lot of features on social media, like the user profiles and the user social network and what the user has been posted. So essentially, we consider all of these kind of features to characterize whether this user is credibility or not.
Gotcha. So through all these steps, you wind up with this social news engagement data, these tuples of a user, a post, and a time, right? So it's the user chose to share some particular URL at a specific time.
Yes.
How is time relevant in the equation?
We want to characterize, right? So for fake news and real news, the spreading process different or not? So we want to look at the time. For example, there is a news coming here. If we can track in the time series of this spreading process, we may find some patterns to better differentiate fake news. For fake news, during the spreading process, usually there's some point of time, there are a lot of people suddenly spreading this news in a very short time period. But for the real news, it's more likely that, okay, people share the news in a constant intensity. It's not like that. The time series should not like suddenly change, suddenly decrease, or suddenly increase. So if we can capture these patterns in this time series, and then we are more likely to can capture, okay, to using these patterns to detect fake news and real news. So that's why we consider the temporal dynamics of the spreading process.
So how strong are those time-based features? What you're describing makes a lot of sense to me that, fake news probably has a strong intensity and a decline, whereas other news will be more constant in some way. But it seems to me there's also things like disasters that will have a quick, shots were fired here. That seems like that might have a similar pattern where there's an explosive amount of sharing and then a quick decline. I guess how separable is the data given the time information alone?
So what we are going to do is that we do not rely on only one specific feature, for example, the time, or what we see in the time series features. We actually will try to consider features from different domains. So for example, as we mentioned, there is a disaster going on. Then if you look at the content, then maybe there are a lot of extreme sentiment going on, right? So there should not be like, I don't like this, I don't like that. They just report the event. We look at the time series features. We also look at the news content features, and then we also look at the features on the social media, which we call the social context. A single feature alone may not be that predictable for fake news, but if we consider the features from different domains, then we have a higher chance to better differentiate fake news.
Yeah, so we touched on the time series stuff just now. We were earlier talking a little bit about the social media feature engineering, but I haven't had the opportunity yet to ask you about the linguistic-based features where you look at the sort of maybe more classic NLP approaches and things like that. What sort of features can you derive from the news stories themselves?
Actually, when we look into fake news problem, I think the first thing we think about is, can we detect fake news just based on the news content, right? It turns out to be really difficult because, as I mentioned, that the writing style, the fake news writing style is really, really similar to the true news. Linguistic features, you can look at a bag of words or n-grams or these kind of things. You look at the frequency of these words, but it turns out that there's very few differences among true news and fake news in terms of these words. So traditional methods like naive Bayes or SVM or logistic regression, if you only use these linguistic features, it's not that easy to do that. But recently, actually, I noticed that there are other researchers that try to use in like text embedding method, which they try to convert the news or the words into a low dimension vector and then try to characterize how they can use the content alone to do some unsupervised learning. I think that's also an interesting directions going on.
A while ago, I met a machine learning researcher who was working in natural language processing, and they were trying to predict the age of the author of some text. Actually, I think it was age and gender.
Okay.
And while, certainly you can detect those things maybe from text, we intuitively know it's sort of a hopeless fight in a way. Like you'll never get a perfectly accurate predictor of age from language. It just, even though, yes, language changes, maybe older people will use the word Weisenheimer and no young person would say that anymore. These sorts of things you can detect. But for the most part, we wouldn't expect this to have a very high accuracy. What are your expectations about the accuracy we can achieve trying to detect fake news?
That's a very hard question. So what actually we have tried different approaches, right? So what we do is that, as we mentioned, that the users' profiles who spread the fake news is really important. So one thing we're going to do, or we're doing, is that we try to understand what are the people who are more likely to be gullible to fake news, and then we try to understand, okay, in terms of, for example, age, gender, or like their location or other stuff. So we try to understand the profiles who are more likely to be gullible to, and then they share fake news. So we really want to understand why. If we can understand this, then we can develop better strategy to prevent these people to be like gullible by the fake news. We have recently published a paper. We also tried collect some data set from social media, like the people's profiles, and then we try to do a comparison analysis and to see whether the users who spread fake news or real news, they have clear differences or not, and then how they are different. We can use this as a feature to detect fake news.
So what sorts of data sets do you have available to do your training on?
Yeah, I think that's another very important problem for fake news study. So we actually noticed that there are very, very few data sets that can be used by researchers or industry that to explore this problem more deeply. So actually what we are doing is that we are creating a data set which is called Fake News Net. So what we do is, in this dataset, we first collect those true news or fake news from the existing fact-checking websites, such as PolitiFact, FactCheck, to make sure we have the reliable label for this news. And then we try to connect this news with the users who spread this news on social media. So we also collect the information we call social context. After we have this dataset, then we can do a lot of analysis from news content domain and social context domain. So we also recently built a software, as I mentioned. So we will show that how the time series going on for this news spreading on social media, and then how we can using our existing different machine learning algorithm to detect them. We'll also provide a software to demonstrate our result.
Very neat. Tell me more about the software.
We call it Fake News Tracker. We store those data sets we collected as a backend, and then in the front end, we provide some analysis to this data set. For example, over the time, what are the number of fake news shared and what are the number of real news shared? And also we have analyzed the user profiles for fake news and real news, like what's their age, gender, and then how are the differences. Furthermore, we try to build some existing machine learning algorithm and also some advanced algorithm and do the analysis on this data set and provide some result. So we do this software so that other researchers or other community, if they're interested in this problem, they can use our data set and then they can develop better algorithms and show their result. This software we recently won a demo award in a conferences recently. We are very happy to share this to the research community so that there are more people can using this data set and then solve this problem.
So where can people take a look at that?
So it's actually in my homepage. I actually put it in the website, so anyone can access to it using the link.
So we've gone over the problem and some of the data set and the feature engineering approaches you've taken. Let's get into the next stage. What happens when you go to do modeling?
We want to consider the relationship between the publisher, the news, and the users, right? So actually, essentially, we can build a network among these different entities. So for example, between the publisher and the news, we can build a bipartite network. If a publisher publishes this news, that news, and then we have a link among them. And between the news and the users, if the users share this specific news, and then we have a link among them. So after we build this network, then we develop some network embedding algorithm, so which we try to learn the representation of different entities in the network. Apply this representation into some machine learning classifier, for example, logistic regression or naive Bayes or other deep learning classification algorithms. So essentially, our work considers two parts. One is we try to learn the feature representation of news or other related entities. And then the next phase is we use these features to do classification.
And what sort of levels of accuracy do you achieve? Or is that even the right metric? Is it something else you'd look at?
Because we model it as a binary classification problem, then we look at the precision, recall, and F1 score based on our collected data set, which actually appears to be the largest one among all the data set for fake news study. So we have achieved between 70 to 80% accuracy in our data set. Even though we achieve a reasonably good performance, actually there are some issues. We try to also testing our algorithms on a bigger data set, because currently we got this news from a fact-checking website, which they only have a few hundred. So we try to test our algorithms on a larger data set. That's why we try to build a larger data set, and also we're using some machine learning algorithm to generate some data set. So one example is that, as you know, that the clickbait plays an important role for spreading fake news, which means that the title that looks like very catchy and then lure people to click it. So what we do is that we try to using deep generative model to generate these kind of titles to enlarge our training data set so that we can better testing our detection algorithm in a large scale to make it more robust. That's one thing we want to look at as well.
Oh, interesting. So GANs, basically, generative adversarial networks for clickbait creation?
Right. That's what we have done. We usually have a lot of true news, but we only have very few fake news that are correctly labeled. There's a data imbalance problem here, and also the number of fake news is really not that large. So what we do is that we try to generate using as you mentioned, the GAN or VAE, this kind of approach to generate text so that we can capture the distribution and the characteristics of original training data. After that, we have a larger training data, and then we can potentially get more insights on our algorithms and how they work in different scale of data set.
So there's been a lot of successes when people have moved to larger and larger corpora. Many famous examples in natural language processing where things like word disambiguation, as you go from 100,000 to 1 million documents, you don't even need a fancy algorithm. The simplest of algorithms learn just because of the scale of the data.
Right.
Do you think the same phenomenon can happen here, or is it the case that the true signal isn't totally contained in the data?
I think that's a really good question. And actually, I do not really have a good answer for this. As a data scientist, we try to investigate the data from different perspectives and learn if these patterns can help us to better differentiate fake news or not. So if the data scale goes larger, we are more likely to capture the common patterns in fake news and real news. That's why we want to testing our algorithm on a bigger data set, and we try to build a bigger data set from different approaches. But there are still a lot of challenges over here.
What do you think is the most challenging of all these frontiers you've mentioned?
I can mention several examples. One is that actually what we really want to do is we want to detect fake news at an early stage, right? We don't want, a lot of people have already spread it, they already read it, and then we say, we can use this information to detect. That's too late. So I think one of the bigger challenges is we want to do early fake news detection, which means that if we only have the news, if we only have a few people who spread it, can we detect it in early stage so that we can prevent more people to see this fake news? What we are talking about is fake news detection, but actually there's something beyond the fake news detection. we can also look at fake news diffusion process and also how we can develop some intervention strategy over this social network to prevent some people or to be gullible or affected by this fake news. So there are a lot of interesting things going on beyond fake news detection as well.
Well, to wind up, I want to ask you a speculative question about the future. I am old enough that I remember a day when spam email was a major problem. And I feel like today it's pretty much resolved. I use one of the largest email services in the world, in the cloud, and I rarely see spam messages. It seems like they're doing a good job. Are we going to ever come to the day when I rarely see fake news messages?
I hope we can reduce a lot of fake news and then so that you will not see so many fake news messages. But currently, it's still a serious problem at this point.
Well, Kai, this has been very interesting. I'm going to recommend that people head over to dataskeptic.com where they can find the links to both your site and the GitHub page you shared with me and check out your models, and also find a link to your paper there, Fake News Detection on Social Media, a Data Mining Perspective. It's a great survey in addition to covering your original work and the work you did with your co-authors. So for people interested more on this subject, I think that's a great place to start.
Yeah, thank you very much.
Galvanize is a 13-week full-time data science immersive program which provides unparalleled education in a dynamic learning environment.
My name is Julie Kramer, and I'm a former Galvanize student.
If you had any doubts about how pervasive data science is in the world, listen to Julie's background.
Before Galvanize, I had been studying quantitative fishery science. It's a field that involves a lot of statistical modeling. Obviously, fish are pretty hard to count. I was looking to switch industries and kind of expand my skills, and that's what led me to Galvanize.
There's a common story I hear from many data scientists I meet. The course of their normal life brought them to a data problem, whether it's counting fish, predicting trends, or launching a product. When you're looking to take those skills to the next level, that's where Galvanize can help.
The instructors have a lot of experience. They make you feel very welcome. In my prior research experience, I had never really been exposed to big data. So now I'm working with, data like tables that are millions and millions of rows. I've definitely learned many, many skills that have prepared me for my current job.
You've probably heard some of our other segments featuring Galvanize alumni. And I like to learn about their interesting capstone projects.
My capstone worked with the Spotify API. I had been working on a workout music recommender. Typically when I work out, I like to listen to different types of music depending on what I'm doing. I included different types of features like the energy of the music and the intensity and the valence, how positive or negative the song sounded. Also, Spotify has a huge song database, sentiment of the lyrics, things like that.
Galvanize isn't just an education program and network of present and former students. There's also career services to help ensure you're able to maximize the use of the skills you will learn.
Career services is extremely useful if you take advantage of it. Even after the program, they stay on you, and I had kind of gotten a little discouraged because I was applying for jobs and hadn't heard back anything, but I hadn't actually gone out and physically talked to anyone. And our career services resource said, you have to network and put yourself out there for people to notice you. Literally, as soon as I did that, I heard back from a job.
Learn more at galvanize.com/dataskeptic. That's galvanize.com/dataskeptic. Welcome back to the show, everybody. Hey, have I mentioned that the new fake news themed Data Skeptic shirts are out? They're in the store at dataskeptic.com. All right, in the second half of the show, I've got an interview with Mike Tamir, head of data science at Uber ATG and lecturer for UC Berkeley iSchool's Data Science Master's Program. Mike's going to tell us about a publicly available project that tries to classify URLs as fake news and how they built it. Well, Mike, welcome to Data Skeptic.
Thank you. Thanks for inviting me.
So for listeners that are at a computer, maybe I'll direct them from the start here to head to fakerfact.org. For those that are commuting and are going to check it later, can you tell me a little bit about what people will find there?
Sure. So FakerFact was a project that grew out of some ideas that we had in my research lab, which I do as part of my academic work. Fake news has obviously been in the news quite a bit, and a lot of the different companies have been struggling with how to manage this problem, how to handle, especially if you're distributing the big players. It's distributing a lot of links that are shared. You start worrying about are we doing censorship, and maybe that's the only way to solve the problem. And so our idea was that maybe that's not the right way to solve the so-called fake news problem. Don't start with trying to figure out, is this true or is this false? That's certainly important. That's vital for making those decisions. But when you think about how you can solve these problems with machine learning, solving point of fact cases like this new news that came out, there's not going to be a lot of data out there. That's the whole point of it being news. So you have to approach it from a different way. Our hypothesis was that actually the different way that we can approach it is, instead of looking at the points of fact, which are things for fact-checking sites, which we're very lucky as a society to have fact-check organizations, and hopefully there'll be even more of them in the future. Instead, we look at how the article is written. Is it written with, so to speak, the intent of sharing information, so, like the Joe Friday, just the facts? Or is it written with the intention of manipulating, of influencing, of getting the reader to respond, not because of the truth or falsity of the claims, but because of the way they've been framed and the way they've been communicated? This is something that's all predicated on a pretty well documented psychological phenomenon that we're all human. Mm-hmm. That's a phenomenon too, but that we are all human. But the relevant part of that is that humans have evolved to actually not overthink things in certain circumstances. When there's a threat, when there's a tiger in the woods, it's better if we run away, even if we're not quite sure. And overthinking that problem is not advantageous. It would be a poor adaptation to use our full rational capacity to figure out for sure if that's a tiger or to just run away. It turns out that these articles that are maybe not journalism articles, but have some sort of other intent, tend to do. They capitalize and take advantage of the fact that we're all human and that we have these natural reactions.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Show your support by getting a t-shirt at dataskeptic.com.
About that we're emotionally engaged in, and we start responding. And so the whole goal was to see if we could build an algorithm that can flag when that's happening. Sort of like a nutrition facts of what you're reading, right? You can still eat the ice cream, you can still enjoy it, but knowing the calories involved is something that helps us stay fit physically, and hopefully knowing when what we're reading is more for journalism and getting the facts versus maybe not so much that, but for other purposes. Having a tool to figure that out is helpful.
Tell me a little bit about the tool you created. What happens when people visit the site?
Sure. So the actual site, the landing page, you do have to sign in with Gmail to use it right now, and that's so we can get feedback and we can track and keep bots out. Once you're in, and there's a very responsible privacy policy. It gives you the option. You can either take a link that you just read and paste it in there, and then the AI algorithm, which we have lovingly named Walt after Walter Cronkite, will go through every word and go through the different tactics and natural language understanding tactics that we use, and come up with a score. Come up with a score for if it's journalism or not. If it's a wiki, so meant to communicate information but not necessarily news, or not, satire, unreliable, sensational, or if it's an opinion piece, like an op-ed. There's also, if you browse with Chrome or with Firefox, we created extensions. So as you're reading, if you download the extension, you can just press a button, the Faker Fact logo icon in your Chrome extension, for instance, and it'll kind of Shazam whatever you're reading and give you that instant feedback on whether or not it's journalistic and all of those other classifications.
Yeah, I've had that Chrome plugin installed for a few weeks now and been experimenting with it as I read online. It's been interesting to see what I get back. Have you heard from users? How are they consuming it? Are there any maybe journalists taking advantage of this or any interesting anecdotes like that?
There's lots of use cases. For the most part, we built this just to get it out there and give people an opportunity to use it if they want. Mm-hmm. Journalists have been interested in things like they have fact-checking teams. And so fact-checking teams, for instance, they have way too many articles to pour through in order to check facts. They need to judiciously allocate their human time that's spent. And so tools like this are helpful for filtering out the things that aren't worth that human time. I've been in the situation where I'm actually reading from a new publication or an author that I don't know who it is and I don't know what their style and or their biases are. And that's the sort of thing that maybe if you look at the entire corpus of an author, of a journalist, you can see if they have any biases, if they are a journalist and they tend to write articles about facts, or maybe they're more of a pundit, which is okay. And that would just score higher on maybe opinion and op-ed.
So let's start to get into the machine learning side of things. Can you tell me a little bit about the data set you trained on?
Sure. So we started scraping a couple years ago when we first got the idea, not quite 2 years ago. We started from the ground up. Obviously, there are a lot of public data sets out there, which we used. Some of them are very good for journalism or wiki training, of course. Finding the, quote, negative examples or maybe the positive examples for the negative classes, like unreliable news or sensational news. That can be tricky. And the reason why it's tricky is it's not always a slam dunk that every article from a given domain is going to be not credible. Even sites that have pretty bad reputation, if you go through all of the articles in their corpus, some of them may genuinely qualify as journalists. And so we needed to be very careful to curate out those those articles that are not good examples of whatever the class is, and focus only on the purest versions of training data, the ones that are not going to confuse the algorithm. So that's where a lot of the work actually went in, is making sure that we have a low entropy data set, which is just to say that we've got spikes on the very strong examples of not this class, spikes on the very strong examples of genuinely this class, and few examples that are in the boundary. Models that train on those actually perform better, not just on the poles, on the extremes of the yeses and the nos. They actually perform better on the boundary cases too, because they can catch those subtleties and better label when, say, something is a maybe. Maybe it's not journalism, maybe it is journalism. It's somewhere in the middle.
And I think you touched on this a little bit earlier, but can you remind us what the class labels were from the data set?
Sure. So we have journalism, wiki, satire, opinion, sensational, and unreliable.
And would that require sort of a manual categorization? As you were saying, sometimes the domain can tell you a lot of information, but no domain is purely one or, just one of those. Even a newspaper domain probably has journalism, opinion, satire, and maybe some things that are kind of like wiki pages. How much effort went into that sort of combing of the data set?
Quite a bit. What was really important, in fact, maybe the most important mandate of this project, was that we don't allow biases to either maybe being left-wing or being right-wing, or the sorts of biases that could creep in influence any of the data. If you do that, what ends up happening is that your algorithm is biased itself. So we had to be very careful to find consensus across the spectrum on what are good examples of both the positive and negative versions of each class, and make sure that we're only training on the very clear examples there. This is something that also we've opened up. If you do sign in with your Gmail, you can give feedback. It's always the case that the crowd can be wiser than the individuals. And so leveraging that wisdom of the crowds to start to detect if there are any mistakes in the training is really valuable. Now, something's important there when I mentioned wisdom of the crowds. Wisdom of the crowds works when you have three very specific things. Number one, you have a large number of samples. Right? It doesn't work if you only got a few examples. Number two, when you have decorrelated estimators. If people are whispering to one another or influencing one another, that actually harms the wisdom of the crowds. It actually makes the crowd not as wise. A good example of this is in random forest. Random forest is essentially wisdom of the crowd of trees. But if you let every tree train on all the data and all the columns, then they're going to be very, very correlated. In fact, they're going to be pathologically 100% correlated. You've got nothing better than a tree that you then duplicated 500 times or whatever the number is. So getting that decorrelation is really important. And also removing any systematic biases. What we've been focusing on quite a bit recently was actually different techniques for pulling apart that correlation and detecting pathological biases, which is that third thing you need for wisdom of the crowds to work well. And identifying where there might be built-in correction factors, literal bias terms for the bias.
Well, let's talk a bit about the architecture and design. Can you tell me some of the methodologies you use to approach the problem?
Sure. And like any good data scientist, we started with the absolute simplest idea we could come up with. In this case, it was naive doc2vec. So this is where you just take every word, you map it down. FastTech has a version of this as well. You take the average, and then you kind of get this drift in the direction of the vector space that you can then use to do your classification. That validated the hypothesis that there is signal, that what we were looking for did give signal. But as you might expect, it doesn't do the trick. We did several other more modern techniques. In particular, we leveraged LSTMs quite a bit, using an LSTM in order to look at every embedded word and looking at the different kinds of embeddings for each word, looking at them in order. Bidirectional tends to work better. Attention mechanisms tends to be very important, because then, especially for this use case, finding the turns of phrases or the sequences of words that signal well in context of an entire sentence that something's going on, you want to be able to capture that. And so using different kinds of attention mechanisms in order to do that is pretty important. What I just described was this method for going from words to sentences. But you don't have to stop there. You can, that LSTM process with attention is also good for going from sentences in order to paragraphs, and paragraphs in order to entire articles. There are a lot of details in tuning and fiddling how you fit all that together with different architectures, but that's the basic building blocks of how we created each of these algorithms. And different strategies also work with different flavors, different classes. So it's not the same architecture necessarily for every individual classifier.
Oh, interesting. So you've got 6 or so labels. I think you might have trained each in a different way.
So trained them on different data, also trained them in a different way. So there's a lot of ways you can do different ways, right? There's the architecture itself, which we have modified. Some of that can be thought of as just different hyperparameters if you think about like levels and dimensionality at each hidden layer for different places. There's also the mechanism for how you update and how you do transfer learning. That's something that can be very subtle, but also we get the best results when we really leverage the kind of transfer learning that works. So you might think, with some of our labels, maybe we wish we had more, and so, or we wish we were using that more for fine tuning, leveraging transfer from other models, and then adapting for the case that the architectures are not exactly the same. Is really where a lot of the work lies.
So then, when you were saying, you've got the positive and negative examples, my initial thought was, okay, if I'm going to build the classifier to recognize opinionated web pages, obviously you've got the positive examples, and the negatives could just be examples from the other classes. Is that the way you approached it, or is there something more to it?
Right. So for opinion, now keep in mind, these labels that I mentioned are not necessarily orthogonal. Opinion hopefully is going to be not having a journalism or a wiki article that is opinionated is ideal. Now, sometimes you do. Op-eds will have parts that trigger journalism score, but also trigger high opinion. Unreliable and sensational tend to be, not perfectly correlated, but it's most they're the most correlated of those different labels. So what you have to do is, for every article, you need to not only label what it is, but also what it isn't. So some articles are going to be satire and nothing else. Some articles are going to be sensational, but also unreliable. Some of them are going to be opinion and sensational.
Through all of the training process, and maybe we'll get deeper into it later, but at the end of it, all of the feature engineering and, modeling and sorts of things, what is the form of a document? I can send a URL to your site or use my Chrome plugin. Behind the scenes, a couple steps have to take place, and then you get something that can be classified. What does that something look like?
Yeah, so the workflow is, we have a URL. That URL links to the HTML on the page, and part of that HTML is going to be the actual text of the document, the body of the document. Part of it is also going to be the title. Now we have text for the title, text for the article. Importantly, we do not look at text for the URL. And the reason for that is, again, we wanted to be absolutely meticulous that we are not letting any biases go into the way the algorithm is scoring. And if we say gave New York Times a free pass and it got it got extra points for being just from the New York Times URL, that would be introducing that bias. And so the algorithm only sees the words on the page. and in the title and the body. And if New York Times slips and the editor lets an opinionated article goes in there, it'll be classified in the same way as some of the less scrupulous ostensible journalism sites. Getting back to the process, so you have the words on the page, that those then need to be vectorized. They're actually vectorized in several different ways. Then those vectors go into the actual algorithm, the suite of deep learning algorithms. They're combined in all sorts of ways. And in the end, what you get is a vector that it goes into a classification process. The typical for that is something like that. It's going to be different for every label, but it will give a 1 or a 0 or some number in between for those labels.
I'd love to hear a little bit more about that architecture. As you mentioned, you can start with some naive approaches, and you introduced complexity so long as it contributes value. In particular, the attention mechanism is interesting to me. Do you have a sense of what you're able to capture about the structure of the documents that you couldn't with a more naive approach?
Yeah, so the attention mechanism is important. As I mentioned, because different sequences of words, we don't want to wash that out by looking at the entire paragraph. We want to be able to capture when there is a style of writing or a sequence of writing that's in particular very important. And so attention mechanisms, the audience probably is aware, will pull out this additional vector. That context vector that sort of flags gives weight to the most important parts of the sentence, for instance, or the most important sentences in the paragraph, and so forth. What we found is that actually using some of the more higher degree of freedom attention mechanisms tend to perform better. They tend to do better than just strict affine dot product, speculating beyond that certain turns of phrases are important, or maybe the more relevant piece to, or maybe I can actually elaborate that. Attention mechanism is looking at ostensibly every word, but it's really looking at the hidden vector output from the LSTM, and if it's bidirectional, going from the front to that middle word and from the back to that middle word. So really, what it's looking at is quite contextual of the surrounding words, which is part of that process, and of course, training that jointly with the LSTM is important so that it can keep track of that context for the hidden layers. For the hidden output rather.
So I guess a decade or more ago, we didn't have such powerful machines we have today to use some of the modern methods. The way someone might have approached the problem then would be to do some very careful feature engineering. Maybe do some name entity extraction and count those, or count word frequencies, stuff like that. You'd mentioned applying a number of different vectorization techniques. Is it pure vectorization in that sort of general unsupervised, let's throw word to vec at it kind of style? Or is there any amount of the hand-constructed features that you apply in the process?
Yeah, so no, we did not use those hand-tuned features. Part of the reason why not is that can introduce hidden biases, and it can also, in the best of cases, introduce overfitting based on the selection of those hand-tuned features, letting the data plus the what is essentially the feature learning that the deep learning algorithms do, and let that be guided by good holdout practices. It really is the best mechanism for keeping as unbiased as possible.
Well, Mike, to wrap up, maybe we could talk about the project and next steps. Obviously, you've done a lot of good work here doing some detection of fake news. I don't think you would claim that this solves the entire problem of fake news. How far does it get, and where is there left to go?
The way I look at it, this is a band of sticks is hard to break. An individual twig is easy to break. This is one or maybe a few of those sticks in the entire bundle. There are a lot of really important tools in working on fake news, on eliminating fake news that are out there. This is not a replacement for fact-checking sites. And some of the things that we're looking at is maybe sharing what articles are most highly questioned with fact-checkers so that they know what might need some more direct investigation. Working directly with a consortium of different journalists from across the spectrum so that they can also get that feedback is another way of doing that. Right now, it's the use case is really for the end users, for anybody who wants to just check whether or not this spikes, what that nutrition label is, so to speak. Pretty soon, you can share it on social media. Pretty soon, we'll get the bells and whistles and buttons so that you can do that. Ideally, it's something that people think, well, before I share this on my social media site, maybe I should get a check and then I can share not just what the article says, but also what Walt says about the article.
Lastly, to wrap up on that topic, what sort of accuracy do you get, or F1 score, however you're choosing to measure it?
Yeah, this is something that was remarkably encouraging. I was expecting that this was weak signal and that we would, maybe we get the 70s, maybe if we're lucky in the 80s. The F1 scores are surprisingly high. None of the ones that we have live get below the 90s, and some of them get quite high on the 90s. Now, of course, we are talking about a lot of articles, so that doesn't mean it's bulletproof. And the more of that wisdom of the crowds aspect and the constant improvements that we do, the better.
Yeah, absolutely. Makes sense. Well, Mike, I'll encourage people to check out fakerfact.org. There'll be a link in the show notes as well for them to follow. And anywhere else people can follow you online.
Yeah, I do have Twitter and LinkedIn. It's just Mike Tamir, or at Mike Tamir. And so that's a great source for finding all sorts of information about deep learning and machine learning, which is pretty much exclusively what I post on.
Excellent. Well, thanks again for coming on the show and sharing details on your work.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Show your support by getting a t-shirt at dataskeptic.com.